Today I'm going to discuss one of the 3D dynamic finite element problems that I ran on the Pi 4. I'm using a Pi 4 that has 4 gigabytes of RAM and 32 gigabytes of disk space on the card. And I ran a few problems on the Macintosh, and I moved them here, and I was surprised to find that it was only running 5 times slower than the Macintosh on those particular problems. And so I decided to try some more problems to see what would happen. And finally, I ended up with this 3D problem, which is you can see on the screen. This is the Gmsh input that generated the data, and unfortunately I had to run it on the Macintosh. If you run it on the Pi 4, the Pi 4 truncates, makes it a much smaller grid. It actually comes out to having 34,000 nodes and 27,000 8-noded elements in it, and over 102,000 degrees of freedom. And so I ran this problem statically, and when I run it statically, it runs 7 times faster on the Mac than it does on the Raspberry Pi 4. But when I run it, the full dynamic problem, 50 steps, it runs 18 times slower. And so it's kind of an interesting problem here. I'll go and show you the results of the problem. It's basically so I've got a dump here at each of the 50 steps. Open the dump files. Okay. And so here's what the bridge looks like, and it's showing the square root of J2 prime, which basically tells you where it's going to fail. And I can go here and up the magnification on the displacements to an obscenely large number so that you can see just how the bridge is distorting. Okay, and then let's if we run it now. So you can see I applied a pressure across the top, and the legs are fixed. And so with the pressure on the top, it just sits here bouncing up and down. And like I said, this is showing the square root of J2 prime. And if I go and show the upward direction in this particular case is Y, and Z is through the thickness, and X is along the length of the bridge. And so if I go and change to the Y component of the stress, and run it, you see the Y component is almost uniform and then spreads throughout the legs on the bridge. And so that's kind of interesting to see that it that it really changes perspective there. But this is an interesting problem because it's something that was actually if I had tried to run on the old Cray 1 computers, it would have been a very, very large problem, and it would have required a couple of weeks to run. And here on the Raspberry Pi, it took 1 hour and 25 minutes to run this thing and dynamically do the 25 steps. And so that's actually fairly impressive. And so you can actually run, this has 102,000 degrees of freedom in the matrix. And so this is an example of running a substantial problem on the Pi 4. And with the Mystic program, basically, it uses disk space as dynamic memory. And so if you hook an external hard drive to this that you can use run your problem on, there's basically no limit to the size of problem you can run. It's just a matter if you want to wait for it. Because as these problems get bigger, they take longer and longer. I mean, this was 1 hour and 25 minutes. And so that's an example of running a 3D dynamic finite element code problem on the Raspberry Pi 4.